A Brief History of Aircraft Aerodynamics by Colin Schiesl. We start with the Wright brothers. In the late 1800s, many inventors were trying to create manned aircraft. Most inventors started with a large engine and then worked on the rest of the design. The Wright brothers started with the controls and lift mechanisms before working on the thrust. They designed their flight controls based on birds' wings. One critical part of their design was using camber in the wings. Here is one of the Wright brothers' typical competitors. Our first major design invention is the camber. A camber makes the wing asymmetrical when looking at the cross-section because the top half is larger than the bottom half. This innovation, developed by George Cayley, is designed to increase the lift coefficient. It works because air moves faster over the wing, decreasing air pressure over the wing, increasing air pressure under the wing, thereby creating lift. The lift equation allows for two easy ways to increase the lift. You can either increase the lift coefficient or increase the wing area. Early planes used cambers combined with large and numerous wings in order to increase lift. During World War I, countries began to slowly introduce airplanes for surveillance. There was really no wide-scale use of combat aircraft. They were mostly used for spotting enemy positions. The most common planes at the time were bi- and triplanes because, as mentioned, more wings means more lift. The next big innovation came after the war. We saw the abandonment of wooden and cloth planes in favor of metal, most commonly aluminum. While metal does add more weight, it is sturdier and allows for greater fuel capacity, increasing range. Wood was phased out because it becomes weak with exposure to moisture, and wood joints are weak compared to welded joints. On May 6, 1937, the Hindenburg, a hydrogen-filled airship, crashed and was incinerated. This event marks the end of seeing airships as a possible solution for large-scale air travel, thus increasing research efforts for airplanes. World War II saw one of the greatest periods of aviation innovation. Notable inventions were fast, lightweight fighters and powerful long-range aircraft for cargo and bombings. Logistical issues, including the need to land in odd places like short aircraft carriers and impromptu airports, gave rise to even more innovation. Flaps are one of the most important inventions in the history of aviation. They are located at the front and back of plane wings. The goal is to maintain low drag at high speeds, like at cruising altitude, while also having high drag and lift at takeoff and landing. This is achieved by being able to change the shape of the wing mid-flight through the use of flaps. Flaps allow for shortened takeoff and landing distances. High lift at takeoff and high lift and drag at landing are preferable. Leading edge flaps are located at the front of the wing. Kruger flaps, the most common type, are extended from under the wing to a position in front of the wing. They are located between the fuselage and the engine. Slats are located from the engine to the wing tips and are extended outward from the wing. Takeoffs rely heavily on leading edge flaps and slats to increase airspeed over the wing, increasing air pressure under the wing, and thus increasing lift. Trailing edge flaps are located at the back of the wing. Landing relies on leading and trailing edge flaps. One of the most important aspects of trailing edge flaps for landing is a slit between the wing and the flap. It allows for a small stream of high pressure air to interact with the low pressure flow moving above the wing. This delays the separation of the boundary layer, keeping the airflow above the wing laminar. Landing requires slowing down from cruise speed, which is about 500 knots, to landing speed, which is about 140 knots. If the plane lands at any greater speed upon touchdown, the tires will spin too fast and explode. The plane needs to slow down while also decreasing altitude, which naturally increases airspeed. The solution to this is to increase drag using trailing edge flaps in order to shed airspeed and altitude. Winglets are a more recent invention that help improve aerodynamic efficiency. When the high and low pressure air from above and below the wings mix at the end of the wings, they create air swells. These air swells create drag and can be dangerous for aircraft passing behind them. Winglets are placed at the end of the wings to reduce the pressure differential and decrease drag by up to 20%. I hope you learned how fluid mechanics has been integral in the development of modern aircraft. Now enjoy some famous aviation pictures. One of the early flight attempts. This guy must have been brave. Bring our boys home safe.
Oi, Ringo, we're not in Liverpool anymore thanks to this Boeing 707.
If they didn't design this plane right, they would have surely been taking a stairway to heaven. The history of aerodynamic innovation has all been culminating in order to get Larry in the air.